Hi there! Dr. Maria Wheeler-Dubas here, Science Education Outreach Manager here at Phipps Conservatory, and this week I'd like us to explore something kind of fun about pollination. In a quick overview, pollination sounds like a pretty straightforward topic. A bee visits a flower, gets some nectar, accidentally picks up some pollen along the way, then travels to the next flower, maybe drops off some pollen and gets some more nectar. Win-win for everybody. And that is true, but that's not the whole story. As with everything in nature, the whole story is a whole lot cooler. So let's check out some of the adaptations required for pollination.
So first things first, a pollinator is anything that moves pollen from one flower to another. Pollinators can be some sort of insect, but they can also be birds, lizards, bats, or other types of mammals. And this is super biologically important because pollen grains carry the precursor to the plant version of sperm. So in essence, pollinators are help guiding plant reproduction. So now we can talk adaptations. Different kinds of organisms have different specializations that help them get to flowers, and in turn, pollinate.
Some super adaptations for pollination are based in morphology, the shape or structure of the animal.
Special morphological adaptations that aid in pollination take on a wide range of forms and can include things like long tongues, or tongues with brushes at the ends like lorikeets have to collect nectar, long beaks, or proboscides, the plural of proboscis. The world's largest pollinator, the black and white ruffed lemur, has dexterous little forepaws that it uses to open up really tough flowers like those of the traveler's palm. Once inside the fibrous flower, the lemurs will eat up the sweet, rich nectar and ultimately end up moving pollen around from one flower to another. Or we can think back to our animal movement video to note how morphology reflects function, like in lizards who pollinate. Yeah, it's pretty much like that.
Hey, speaking of the bright sun, some insects can actually see colors in the UV spectrum.
The ability to see UV light means that some insects' views of flowers can actually be pretty different from what we humans see. A number of flowers have markings invisible to us that help guide insects to the nectar and pollen.
It's like a roadmap to yumminess.
Now have we thought about a flower's smell? If you've ever breathed in the sweet floral scent of jasmine or inhaled the gnarly stench of a corpse flower, you probably already know that flowers have a wide variety of chemical cues that they can emit to attract different kinds of pollinators. And as a result, pollinators have a wide variety of chemosensory adaptations to help them pick up those different chemical cues. Many insects have chemoreceptors across their body, often concentrated on the ends of antennae and places like the tarsi on the legs of butterflies. These chemoreceptors help insects pick up information about the world around them in a similar way that we humans might learn about our environment through chemicals we pick up with our sense of smell.
And some insects even have electroreception, the ability to detect faint electrical fields around flowers.
But don't worry, it's not like a bzzz risk. It's more like a bzzz, oh, there's a flower. If we look at bees, their ability to detect electrical fields is kind of like our ability to feel static electricity after rubbing a balloon on our head. The bees can detect the charges as it ever so lightly moves the tiny hairs on their body. This helps direct them to flowers. Cool, huh? Oh my goodness. And this is all just scratching the surface of the amazing adaptations that pollinators have to aid in their quest for food sources. Some pollinators can detect temperature gradients and even humidity gradients around flowers, and we haven't even talked about how size and flower shapes are related. There's just still so much to keep learning. It's pretty cool though, huh? So thank you so much for joining us today. I hope you've enjoyed learning a little bit more about the different adaptations of pollinators. Now let's go out and explore this beautiful wild world.